right, gang, let's get the show on the road. Good evening, everyone, and welcome to the Winnetka Village Council study session.
Just bring it close to you.
Are these the new ones?
Yes. Is it working? They're working.
Hello? There we go. The Winnetka Village Council study session for July 11th, 2023. I'd like to call the meeting to order. Ask everybody to mute your cell phones or other electronic devices. And I will ask Rod to do a roll call for attendance.
Thank you. Trustee Dahlman? Here. Trustee Dearborn? Here. Trustee Handler?
Here.
Trustee Orsick?
Here.
Trustee Apatow? Here. President Ritz?
Here. All right, item 2 is public comment. If anyone in the audience would like to speak about an item not on tonight's agenda, which is the Winnetka Electric System and Power Plant overview, you are welcome to step up to the podium and share your thoughts with us.
Hello, not surprisingly, Ted Winnichenko. So I came by to, well, I'm going to stay for the meeting, but I wanted to say first that I was very pleased generally by what happened last week. And I am now hoping the council will expand on that and continue to turn words into action. So as the email just sent, I'm just going to recap it. 1998, the Bertlings Hill sidewalk was closed because of resident complaints, and there was a lot of discussion. If you go through those meeting minutes, you'll see there were like dozens of people that spoke in both directions. They did a study. The police chief at the time commented on when the sidewalk was closed that increased foot traffic of students after school along Winnetka. And they decided at that point that they would close it until they could find a solution to reopen it. And then, in 2010, not knowing this, I'm gonna just repeat this. It was tragic when one New Trier student hit another, sent them with brain trauma to the hospital, ended up in the Cook County jail because their parents couldn't post bond because it was officially a hit and run. This young woman drove to her house and was found crying in her car outside of her house. But officially, it was a hit and run because she left the scene of the accident. And I now wonder why. I now wonder if closing that sidewalk in any way contributed to the density of students on that corner and to the tragedy that occurred there. And then 3 years ago, this council, this village was approached by the owners of that property, and in secret, there was never any indication that that sidewalk was going to be vacated. It was never identified, nothing. They made a decision to sell that sidewalk, and that decision was made, according to an email from Brian Norquist, before the first notice of public action on this matter. That meeting in November was pro forma. The council had made a decision, they had received payment, almost, and they moved forward. And I thought it was done. I was sad, and I thought it was done. But luckily, there is an opportunity to correct this because the ordinance required that payment be made within 30 days, and the ordinance stipulated if payment was not made in 60 days, the council could, by resolution, repeal the ordinance. And as it turns out, the last payment for that was received last week. Last week, after I asked why there wasn't a payment there. It appears that the village went out to that property owner, got them into the village hall to make that payment, but it doesn't matter. That payment was 60 days late, and at this point, the council has the opportunity to repeal that ordinance, and I think it should. If it's really a great thing, you can reintroduce it, and now that the public will be aware of it, there could be discussion. There was a lot of discussion in 1999 about it, and you can sell it again. But if you don't, then I guess the idea that, and I'm going to quote, I believe the words were, hold on, the public land that we have here in this community is very scarce, and that every single piece of property we own, we should hold on to the best of our ability. I totally agree. The post office is an example. Dwyer Park is an example. The lake shores are an example. And in my opinion, a safe passage from New Trier to the west is another example. And I feel that we are giving up way too much by selling it. Oh, and the last thing I'm going to mention, I'm going a little over today. Most people go over lots. But The last thing I want to mention, I found it interesting. When you look at those emails, the person that didn't make their last payment, their emails essentially complain about the fact that they're paying too much to get the sidewalk for free. They were unhappy that the cost of removing the sidewalk had gone up. Essentially, they were disappointed that they couldn't get the sidewalk for less than nothing. And I just find this tragic. Thanks.
Would anybody else like to address council? Come on up, Tom.
I suspect you don't get many things but complaints, but I'm going to add myself to the list. My name is Tom Brown, 1172 Hamptondale, the avenue where the wood chips flow. It's the Hubbard Woods neighborhood. I had occasion to walk across the bridge at the Hubbard Woods train station, and there's a crew working on it. And I asked the fellows there, 2 men, what's going on? They said, oh, we're doing a little patchwork. I said, isn't it the occasion at this juncture to replace this whole thing? Do you think it's got the structural integrity to last much longer? Oh, no, this thing really needs to be taken down and put back up. They respond. I said, well, when do you think this is going to happen? It's not going to happen for years. I said, years? Oh, yeah, Union Pacific. I said, we've been told time and again that it's imminent. I've talked to Brad Schneider's staff. I've talked to individuals in this government. I've talked to anybody that listens to me because I'm tired of talking about it, but it's always imminent at some point. And people seem to have different ideas of when it's going to happen, where the money is, where it's coming from. The point I would make to you, and I'm sure it's been made many times before, is you talk about the beauty of Winnetka. You talk about how much we love Winnetka. And the first impression, so many people come, my guess coming off that train, it's like a third world Lebanese bombed out area. And you think, welcome to my village. And I'm sure I'm not a structural engineer, I'm sure there's structural integrity issues, because it certainly looks like chunks of concrete are coming out on the bridge. It just looks horrible. And when is it going to finally be fixed? I don't know what we need to do. I understand there's a tussle between you and Union Pacific and perhaps the state government, other players, but whatever force we can bring to bear, whatever leverage we can bring, I think it's time. These guys are doing a patchwork fix. In my book, that signals they're kicking the can down the road. You don't do a patchwork fix if you're going to take down the bridge tomorrow. You do a takedown of the bridge now. Putting patchwork into place is a clear signal to me, and I think a lot of others in the community, this ain't going to happen. And I beg the village to intercede with the government or something to say, we're watching this. It's a long time coming. The time is now. Patchwork is not the answer. Thank you.
Thanks, Tom. Could you look into that, Rob?
We've looked into it routinely. We actually have a Zoom call tomorrow with representatives from Metra on this very matter. So I think we've let the council know from time to time that the funding is there. The problem right now is Union Pacific holding up their sign off on the submittal of the permits. So the funding is available and UP has to sign off on it, and they haven't.
So Union Pacific owns Metra?
Union Pacific owns the facilities.
They own the railroad.
Yeah.
And you can't touch anything
Right.
on the railroad, in the right-of-way, or above it without Union Pacific.
Right. Correct.
Do we have anybody on, we
We-
look at Union Pacific's board? Do we know anybody?
No.
No.
We know nobody?
They will not budge.
Wow.
I think they're patching because we brought to their concern
Correct.
that there had been, I think, a personal injury, right?
Now, I'm not aware of an injury, but we routinely keep them informed about the status of that bridge and whether it should be inspected, and they go out and inspect it, and they have to tend to it until such time it's taken down.
Have we done our own structural review of it?
No. We've asked, they have done their structural review
And they,
and determined that it is safe, but that it needs maintenance all the
Yeah, yeah,
time.
okay.
So,
So, thanks, Rob.
Yep.
Anybody else like to speak? Come on up, Patrick.
Very briefly, I just wanted to say hello. My name is Patrick Hanley. I lead the EFC these days, and I just wanted to express to you that I'm excited to hear more about the power plant tonight and lend the support of the EFC on anything that comes out of this evening's conversation. I know myself and the commissioners are passionate about the issue, and I hope that we can be helpful. So looking forward to learning more.
Awesome. Thanks. Anybody else? You're the last man standing if you'd like to say something. Okay, I'll close public comment after that. All right, item 3 tonight is the Winnetka Electric System and Power Plant Overview. Tonight, council will be provided with information on the electric plant functionalities in order to assist council with future policy decisions with respect to the future capital investments. Our Water and Electric Director, Brian Keys, is here to review. Just to kind of go over things, what I'd like to do is let Brian go through his entire presentation uninterrupted. So if you want to keep notes as you have questions throughout his presentation, that would be great. We will then go to the public for more public comment, and then we'll bring it up here for any final comments and discussion. There's no policy tonight. This is just a learning evening so we can get a little bit smarter about one of our largest assets in the community and start thinking about the future conversations of how we're going to deal with an aging plant in the future. Take it away, Brian.
All right. Well, that's not a good start when you get locked up, right? So, thank you for the introduction. This is kind of an overview of what I want to step through, and tonight's focus is on the power plant, but it's all interrelated to the electric system and how we get power to the village, distribute it, and the role the power plant plays. So we're going to have we'll take a review of the whole system and then delve into the power plant more specific. So as President Rintz indicated, this is again like a background to lay the foundation for what's critical decisions are going to be coming before you related to the power plant. And in the current 5-year capital plan, there's $3.6 million of capital projects solely for the electric plant for continued operation. So our power supply, our power is provided at the wholesale level from the Illinois Municipal Electric Agency. That is a contractual arrangement that runs through September of 2035. On our behalf and 31 other communities, the agency, or IMEA, makes purchases on the market, has purchase power agreements, has ownership in 2 plants, Trimble County and Prairie State, and uses member generation. I think there's 18 or 19 members of that 32 that have their own generating assets to meet the membership's power requirements. And they're responsible for determining that portfolio that does that in an economical manner. When we entered into that contract, the village dedicated the output of the power plant to IMEA. So the simplest way to say it is they decide when we run. They make a call to tell us when they need to run, and it might not be for a local need. It might be for, in this case, Northern Illinois, or even going out to the East Coast. They're looking at pricing. They're looking at local emergencies. And in return for that, we get what's called capacity credits. It's $1.4 million annually. And the way it's applied is 1/12 of that is taken off our wholesale electric bill each month. And lastly, although that contract period is out to 2035, there's already talk about the agency needing to start to re-engage members about their desire to remain beyond 2035, because purchase power agreements are typically in the 10 to 20-year range, more so at the 20-year range, and so they can't begin to make those types of arrangements with a contract end date of 2035. So just to plant that awareness, that's forthcoming in the future. This is an illustration. So again, IMEA is getting the power to Winnetka, and in most cases, it's being delivered to us through a transmission system. It's operated by an organization called PJM, but locally it's owned by ComEd. So the power is being delivered on 138,000 volt lines, transmission lines. You probably notice those lines in Northfield when you're at the Marianos, right, running through the corridor north-south. And the power then is stepped down to delivery voltage of 12,470 volts. So if you imagine, we have 3 places we can get power from: our Northfield substation, our ComEd tie lines, or the power plant. So in the middle of this diagram, you see the village of Winnetka. On our peak all-time summer load is 40,600 kilowatts. So we need to use during the week or on peak summer periods, we're looking at 1 or 2 of these sources to provide the electric for the village. So I'm going to delve into these in a little more detail before we get focused on the power plant. So our Northfield substation is called Northfield because it's located in Northfield, near the New Trier campus, right along the ComEd transmission line. It was constructed in 1996. Again, it steps the voltage down from 138,000 volts to 12,470. That's the delivery voltage of our distribution system. And when it was constructed, it was a one substation transformer rated at 30,000 kilowatts. And for those of you that have been on the council recently, and for at least for the public, we just completed a substation expansion project in 2022, where we added a second transformer, so another 30,000 kW of transformation, fire protection, a firewall, and circuit breaker. So this, in a sense, made that substation much more capable of delivering power to the village. The other source that we get when we're not generating is we get power delivered from ComEd. So we're not buying power from ComEd, but we're being delivered through their 12 kV distribution system. This started back in the 1970s when the village's load was larger than what the generating plant could handle. So they actually connected, the first interconnected connection to the adjacent system was through 12,470 volt lines, or we commonly call it 12 kV lines, to ComEd. And these run to their substation in Northbrook. Two of the lines go to the South Load Center, which is a distribution center. It's right across from President Rint's house on Spruce and Berkeley. He's our neighbor. The other one runs all the way down to the plant. So these load centers, the best way to describe them is it's a building with circuit breakers for our circuits that serve our village load. Our interconnection point with these tie lines, where it kind of transitions the ownership from ComEd to Winnetka, is this large metering enclosure that's located behind CarMax. And at that point, this probably nominally 7 or 8 mile underground circuit goes from ComEd's responsibility to Winnetka's responsibility. So from that metering point all the way into town, Winnetka owns and maintains that demarcation point. Those 3 lines, we have an arrangement that we can bring in on a normal basis, 21,000 kilowatts. And then the last one is the electric plant. So we have, again, coming back to, we have to have power coming into the village all the time to meet your load, whether it's your residential properties, the schools, or businesses. And so those combinations of sources. The at the power plant, there's 3 steam turbines that can generate 25,350 kilowatts, and there's 2 diesel units. Now, we'll talk more on those in more detail, but it's at the high level, those are our 3 power supplies for the village. What's important to note is that, prior to the substation expansion, we needed to have 2 legs. Really, we had to have the power plant as a backup system. So imagine, I said nominally we needed 40,000 kilowatts, and the substation only originally was constructed to handle 30. If something happened at that substation, we could get 21 from ComEd, but we had to make up the balance from ComEd, from the power plant. So now we have actually 60 available at the Northfield substation. So we've now have even more redundancy of power supply, and we're not solely reliant on the electric plant for system contingency. So that was one of the big rationale for moving forward with the substation expansion project, is reducing our reliance on the aging infrastructure at the power plant for system contingency. Now, again, this not to intentionally a duplicate slide. We've talked about the power sources on the outside. So we got the ComEd tie lines, the substation, and we'll go into more detail on the power plant. In the middle, that's our distribution system. So how do we get the power from the ComEd tie lines to your homes? So first, there's 3 12,000 volt circuits that run between these distribution centers and the Northfield substation and the electric plant. So this allows staff to transfer power between those distribution centers by opening and closing switches or tying things together. We can transfer between those power sources where our the load from your homes and businesses is being carried. At the street level, we have 9 12 kV circuits and 4 4 kV circuits. And the 4 kV circuits are the older circuits that are originally installed that terminate or originate from the power plant. And the load that's served by the 4 kV circuits is the public safety building, the AT&T building, 2 of the 8 feeds to Northfield, to New Trier's campus, and the reservoir at Willow Road and the Public Safety Complex and the Willow Road Winnetka Avenue Pump Station, or Hill Road Pump Station. So the 12 kV circuits, as I mentioned, those load centers, those are breakers, and those circuits originate about a third of the circuits come out of those different distribution centers. So across, again, it's using President Rintz's neighbor as an example, at the South Load Center, there's 5 circuits that are going to distribute power to geographic areas of the village. To get it to what you actually, plug into your wall, 12240. So I mentioned we're distributing at 12,000 volts or 4,000 volts. We have to step the voltage down, and there's distribution transformers located across the system. Generally, they're spread equally around the neighborhood to cover the load. And so what you'll see here is in the bottom pictures, you have an overhead transformer, and then you have the equivalent version of an underground. Those are single-phase transformers that would use to serve a typical residential customer. And the service voltage for your house is 12240 volts. So when you plug into an outlet, it's 120 volts. If you had an electric dryer, it's 240 volts, or your oven's on 240 volts. So the distribution system is taking this what we call medium voltage in the industry talk, 12,470 volts, and we're stepping it down to what the customer needs. Now, a customer like Fred's is looking for 12208, that's a 3-phase power. A large industrial customer would be New Trier High School, they're looking for 277 480. So it's, again, what's the customer's utilization voltage? And then lastly, there's step up and step down transformers. And this could be considered almost beyond distribution, but substation. So what happens is outside the fence if you've been down to the power plant, there's a brick building at the base of coming down to the power plant. It's a small single-story brick building. That's actually the plant load center. So there's 12,000 volt breakers in there. There's a fenced-in transformer yard. That's where these transformers are actually physically housed. On a day when we're not generating, the power is coming into the village at 12,000 volts, whether it's coming from our Northfield substation or our ComEd tie lines. We step the power down from 12,000 volts to 4,000, and it's serving the power plant, the lights, the heat, the pumps at the water plant, and it's serving those 4 kV circuits. So on a day like today, the yard's power is coming in from ComEd. It's being stepped from 12,000 volts down to 4,000 volts, and in a circuit that feeds the Public Works Complex on Willow Road. It's a step down, they call it step down or step up. Now, when it becomes a step up transformer is a day when we're generating, we're going to talk a little bit more about, but the generation, when the generators are running, it generates the power at 4,000 volts, 4 kV. And because, as I mentioned, our distribution system is 12, we have to raise the power up to the distribution voltage. So the transformer really doesn't care which way the power is flowing. In one case, it's going to take power and reduce it down. On a day when we're generating, it's going to take the power and reduce it up for our distribution system. What's important to note on this slide is that coming before you at a future date is that you'll see that the transformers are 3 of the transformers, the spare and 2 in-service transformers, are from 1970, and so they're scheduled for replacement. So we're actually in the process of doing design work for speccing a replacement transformer on one of these units. And this is where we kind of start to focus on the power plant. So in the simplest analogy, the way our steam turbines work in the upper right is you have some type of heat source or a fuel source. So in this easy example is you've got a flame feeding the boiler, which is a tea kettle. The steam's turning a little turbine, and then it turns a generator and creates electricity. Simple model that's really analogous to how it works on a bigger picture. So the picture in the bottom is not exactly our same system, but pretty similar to how we used to generate power. So in the lower, you had that ash pit, and the flame was fired by coal. Coal was in this boiler system, and in the case of the Winnetka power plant, that boiler system is 3 stories in that, and I have a photo of it, but it's 3 stories tall, filled with tubes. The steam's coming off, the high pressure steam's coming off. It goes through a turbine. It's forcing the propeller, or if in layman's terms, a propeller of the wheels to turn, and it drives a generator, and it generates electricity at 4,160 volts. That's so when we're running. Then all the components in the bottom, you have hot well and condensate pumps and feed water pumps. Those are all elements of returning the water or high pressure steam back into the system so it's recirculated, it gets reheated, and runs through the process again. So this is, in our case, in 1990, and we'll talk a little more about this, but in 1990 we stopped burning coal and they converted the boilers to natural gas. So our heat source for the steam units is natural gas, but we still have actually a boiler system and tubes, and then it runs through. On the next slide, slide 14, I'm not going to go through every plant addition, and to be honest, I'm probably not the best historian for stuff prior to 1978. The plant really started, I mean, if you read some of the historical lessons, started with, it was a big event in the early 1900s to have streetlights. And it was, in some of the documents, is a little steam-driven units to a modern plant. And we probably now, modern's in parentheses because we're no longer modern, but at the time, they viewed it as transitioning from just little steam-driven units to a modern power plant. The last addition here, and you'll see mentioned later from 1960 to 1978. In 1978, that last capacity addition was the 2 diesel generators, the Fairbanks Morris units. So as I mentioned earlier, our initial fuel source was coal. We stopped burning coal in 1990. They converted the boilers over to natural gas. And then we have 2 diesel units on site. And originally the diesel fuel was stored up in what's called Tower Court. And we went through a project in roughly 2008 timeframe to remove those tanks, and we built a tank farm with the 20,000 gallon unit down at the power plant itself. So the takeaways on this slide is basically it's high pressure steam, so it's very exceedingly hot, 775 degrees Fahrenheit. And the total steam capacity of the 4 boilers is 344,000 pounds. And you're going to need all 4 boilers to run three turbines. So one of the challenges as we look forward is we're going to potentially need to make some boiler improvements. If we don't have the 4 boilers, we won't have enough steam to run the maximum output of 3 turbines. They're set up with, again, where basically you have passages between them. I got a photo to help illustrate this. They're fired on natural gas. There's a big control panel, and basically it's all ducted into a common exhaust, which is what we all call the exhaust stack at the power plant. So the youngest boiler down there is from 1968. Which is 59 years old, and the average of all our boilers is 71 years old. Interestingly enough, is that the oldest boilers are not our worst performing boilers from a perspective of maintenance, repairs, and tube failures. 3 of the boilers can theoretically run diesel fuel oil to fire them. From a practical standpoint, that would not happen for the following reasons. One, when we made the decision to go from 100,000 gallons of fuel to 20,000 gallons, you would have to have a line of semi-trucks dropping off fuel to keep up with it. 2 is when we did our air permit renewal in 2018, that criteria we were able to retain the ability to fire them on fuel oil, but it was only under an emergency condition that we could fire them on fuel oil. The last time it was done was in Y2K. At midnight, apparently the decision was prior to midnight was to have some of the boilers on natural gas and some of them on fuel oil because, again, the concern that the world was going to drop out on Y2K, which obviously didn't happen. So from a realistic perspective, while permitted under certain conditions, we would never run the boilers with diesel. Again, it's 4 boilers. They get you to the 344,000. And kind of, again, this is a context or a background, but we need all 4 boilers to make the maximum output of the turbines, which we're going to talk about next. So again, for those that haven't had a chance to see the power plant, this is the boiler combustion control panels. And if for some people that are my age or older, you don't see these little ink pen charts too familiar. This is, again, we kind of passed modern and we're on the antique trend, but we still have pen charts down there. This is the burner controls for 2 of the boilers. Slide 18 is a section of one boiler, so you can walk between them. This is basically, let's say, two stories that you can see in this photo, but it goes all the way up and it goes into the basement. So the boiler assembly is huge. It's probably in totality 4 stories. That brick, that's the outside of the boiler. Inside of it, there's concrete refractory, and then it's filled with different types of tubes. There's the firewall tubes and the generating tubes, and then you have the burner at the bottom, and it's a large natural gas burner. So the employees we refer to it as the turbine deck. So again, when you walk in the doors on the east end, you see that large open area, 4-story ceiling. So that's the turbine deck. On that turbine deck floor, there's 3 Westinghouse generating units. Again, the total of the 3 is 25,350 kW of output. They have condensers that help condense the steam back into water for returning to the boilers. And on the lower level, some people might call it the basement, we got 2 diesel units from 1978. They're Fairbanks Morse units. I got a typo there, Morse. The total of the 2 units together is 4,700 kW. So again, this is, again, you can see the age of our generating assets. The diesels, as I mentioned before, installed in 1978. And the average age of the other units is just a little over 69 years old. And if you add these numbers up, that's where, right here, I need 304,200 pounds of steam. So again, you got to have the 4 boilers to get your total net output of the 3 units. Each of the units is sized a little differently. And so their net capability, this is a recent test data. So 8,650 kilowatts for unit 4, 5,500 for unit 6, 11,200 for unit 7. And then diesels had slight variances in how they tested out, but nominally is 2,365 or 2,359 kilowatts. The difference from an operating perspective is the diesels are quick start. You can have them online 30 minutes. Takes an operator to do it. It's not like your home generator where it turns on automatically for you. Someone's got to be there to start it up and interconnect it to the electric system, but it can be done in under 30 minutes. The steam plant takes hours to start. That was another concern with the contingency perspective. So we haven't run, so the boilers are cold. To get the full output, it's probably 8 hours from the time we start the boilers. That tea kettle in that upper right-hand corner, start those tea kettles. It's going to take us 8 hours till we have full production of steam, and we can run all 3 units at maximum output. So that was one of the concerns, was even when we had the power plant as our only system contingency, there was scenarios at different points in the years where it would take somewhere around 5 to 8 hours to get the system recovered if we were relying on it as our only contingency. This is, again, to help illustrate the size. This is one turbine. So on the far left side of the picture, you have the steam coming in. It's driving the motor assembly, and the power is coming out on this end here. So it's coming in and goes through a blade assembly. The steam's being forced through, and at this end, the power's coming out. And this is the rotor. For those of you, probably most of this council, we approved a rotor repair. This is where the rotor is housed. This is where all the steam components are housed. And this is basically a part of what's called the exciter, where the power is actually coming out at this point down here, going into the basement over to some switchgear. So again, rotor, steam path. The boilers are back in the very back section of the building. This area is the operator booth where they're running where they're monitoring the system. It's tough. Apologize, a little tough to envision if you haven't been down to the power plant. This is one diesel generator. So on slide 22, it's one of the two diesel generators. And the best way I describe this to like friends or family, they ask me what it looks like, is if you ever watched a World War II movie, like a submarine or a big destroyer, it's like, that's what this reminds me of, is a diesel generator to be on a ship. Some of these are actually used, similar units are used in Dutch Harbor at like fish processing plant. And I only know that because one time they called trying to get spare parts from us. So all that power has to get back to the system. So there's basically, they called it switchboard, but there's breakers, again, similar to a breaker, can connect to something to the system, and as well as it can also, whether it's coming in or going out. So the generators are connected to switchboard at the 4 kV level. The breakers, literally, you know, in your house, you have a little breaker slot that's, you know, you flip a lever like this. These breakers are probably as tall as I am, and they're called truck type because they roll out on a big dolly assembly when they go in and out of the cubicle. They have relay protection on them. Some of it's been upgraded to current microprocessor based, some of it's still old electrical, mechanical relaying. And then it was actually a really good design from a contingency planning. They actually have two separate bus, well, we refer to it as three, but it's one lineup that's called the north-south bus, and they have a physical separation, a wall, to what they call the east bus. And that was done for contingency planning, that if they had a problem on one bus, like a severe electrical failure, that wouldn't take out the other bus. So it actually has a physical separation. And that's what it looks like. So on this is the north-south bus. The levers at the top allow the operators to transfer power to what they refer to as the north bus or the south bus, a bus being an electrical bus bar connection. And then these cubicles in the front, that's those, as mentioned, breakers and relaying. So the dials, these are the controls for both coming in. You'll have generators connected here, and you also have 4 kV circuits going out into the distribution. So this is what we call the 4 kV north-south bus. And again, you have power coming into it and the ability for power to go out to distribution circuits. And then this is the east bus, so it's physically located on the other side of a brick wall, very similar. You've got some of the generating units are connected to it, so generation can provide power to the bus. And we also serve circuits off of this bus. So the next part is the IMEA generation contract. So how does this all work contractually with IMEA? So again, as I mentioned, we have dedicated our capacity to the agency. So they call us and tell us when they need us to run. And that call generally is how much power they need and how soon they need it. So it's like, how many units do we need to run? And then also, how fast they need it is a combination of a kind of a back and forth discussion. We need this many megawatts by this time. How much power can you give us? And then there's some contractual obligations, which I'll walk through in a minute. In return for that, we get capacity credits, and I've simplified that in my prior comments. It's 1.4 million a year. This is how it's actually calculated. So basically, each unit has its output, and for the steam turbines, the contractual rate is $4 per month per kilowatt. So down here, if you look at unit number 4, its tested output was 8,650 kilowatts, $4 a month. 4 times 8,650 is 34,600. On an annual basis, number 4 turbine provides $415,200 of credit to our wholesale bill. On the flip side, you might have remembered me saying when we had the rotor outage that for every month it was not in service, we were losing $34,600. That's where that number comes from. So it was out of service, it was unusable to the agency, then we were not eligible for the credits because it was not functioning. The diesel units are compensated at a level of $3.20 per kilowatt month. So it's, again, their tested value times 320, and you get nominally $7,500 a month for each unit, totals out to $90,800 for the year. So the sum of all the units is 1.4 million. And that's applied directly 1/12 of that to each month of our wholesale electric bill. To the extent possible, the agency or IMEA does give us advance notice. So they're watching market conditions, whether it's weather, multiple 90-degree days, or transmission system events. Contractually, they could ask for diesel generation output in an hour and steam generation full output in 8 hours. Sometimes they're asking for it quicker than 8 hours, and we basically give them what we can get. So we start firing the tea kettles up, and we roll the turbines and give them whatever we can get. If they give us more than 24 hours, or more than 8 hours, generally they'll give us more than 24, is that the expectation is that if needed, that we provide full load on all 5 units, the 3 steam turbines and the 2 diesel units. The fuel cost, whether it's natural gas or diesel, is reimbursed to the village. So we submit our fuel cost to them, they reimburse that. And they pay what we call 3/100ths of a cent per kilowatt hour of power generated when we're generating. The other part of the equation, though, is the village is responsible for all costs related to maintenance, repair, the labor to run the units, or in this case, if we're talking in a future date, capital replacement, that's the village's decision to fund that capital replacement or the repairs. In the event of equipment failure or inability to run when requested, then they apply that penalty. That's what I mentioned. So it hasn't happened at Winnetka, but say, for example, we don't have operating staff to run the plant and they call, that's a failure to run and we'd be assessed a penalty. In the case for Winnetka, the penalties that we have unfortunately had in the past have been related to equipment failures, like the rotor. So the rotor failed, we had to send it off-site to be repaired, it was off for several months. You don't lose all of your capacity credits, you only lose the capacity credits associated with the unit that's out of service. We're required to demonstrate that our equipment is available for use, and so every quarter, every 4 months, we have to demonstrate that the units will produce 90% of their output. So this is, again, you got to remember that the other members that don't have generating units are, in essence, paying for a percentage of the $1.4 million that the village is getting on capacity credits. And so the way this was structured was, if we're going to be paying you for capacity credits, we want to know that your equipment runs. So all generating members have to demonstrate that their equipment runs once every 4 months. The next bullet is related to this, is probably one of the largest misconceptions I get from the public, is that IMEA makes us have these generating units. Nothing could be further from that. The village has the sole determination regarding the continued operation or retirement of any or all generating units. So again, we're in an arrangement where they're paying us if we want to maintain them, staff them, and potentially replace them. But it's collectively the village, I'll say the council's sole determination on how long that goes, and if we want to retire one or more components. So it's at the village's sole determination. It's not IMEA forcing the village to maintain generation. In the absence of, an all-out equipment failure forcing it, in theory, we're to provide 1 year's notice before we would take any unit into retirement. So if it's still running and we elect to say that we're not going to run it, we should give 1 year's notice. In the more likely scenario, some type of decision like that would happen after an equipment failure, and we wouldn't be expected to fix it, put it back in service, and then retire it. When the generating unit's retired, we don't get capacity credits. So the other members are not going to pay us for a unit that they don't get the benefit from. Because remember, the benefit is to the whole agency, not just Winnetka. So the agency dispatching our generation lowers IMEA's wholesale power price. And so all members are getting the benefit. That's why I say a non-generating community is willing to, as part of their bill, is paying capacity credits to the 18 or 19 members that have generating units. And the agreement also contains provisions for replacement of generating unit. Capacity is supposed to be replaced within a year. I think in the current marketplace, that's would be tough to do and would require some other discussions, but when the agreement was set up, it was conceptually based on replacing it a year. And then there's provisions in there that it's like for like on the size. So you can put in something bigger, but they're only going to commit to paying the capacity credits under our current agreement. So for example, if we have a 9,000, I'm just using round numbers, 9,000 kilowatt generator, and we decide to put a 10,000 kilowatt generator in, they're only obligated to pay us for the 9,000. That's consistent with their original agreement. And I'll move into kind of giving you a sense of how often we're called. So the vast majority of the time, we're in a standby mode. So again, as I mentioned, we run to demonstrate every 4 months. We can also do some maintenance runs to make sure the equipment, if we have to test something on the equipment, train staff, we can do maintenance run to make sure we're ready. We typically get the call to run in severe weather conditions. And the severe weather can be not only in northern Illinois, but all the way to the East Coast, because that's, again, our transmission market. Usually it's 90-degree, 3 90-degree days in a row. You can almost bet we're going to be running. In the last couple years, now we're running in the winter months for what I'll call polar vortexes. So prior to Christmas last year, we were running the diesel units. And you got to think through the market conditions. So the reason we weren't running the steam plant was the steam plant requires natural gas. A polar vortex is the worst time for us to try to take gas off the system because that's when everybody needs it for heating. So the only practical thing that can be dispatched in the winter months is the diesel units. Well, typically, it varies, but I'd say generally 17 dispatch events is pretty typical. When I say a dispatch event, what that might look like, and again, those 90-degree days during a row, is we might put generation on in the morning, the steam plant on, because again, it takes multiple hours to get ramped up. So we'll start the boilers maybe on at 2 or 3 in the morning. The day shift will come in, they'll start putting turbines on. The agency's usually looking for full output from about 3 to 7 p.m. So as they're ramping those steam units up, then again, saying that, you know, going back to that, I could put the diesels online in 30 minutes. I usually like to warm them up if it's not an emergency. Those will come online at maybe 2 o'clock. They're at full load at 3 o'clock. And so by 3 o'clock, you, in theory, if they're requesting it, you could have full load from 3 o'clock to 7 o'clock, and then they usually start backing us down. The diesel units, they'll tell us just take them offline because they come on and off quick. But if they think they're going to need us later in the week, those steam units will be manned 24/7, might go 3 days or in a row. So we'll bring them, lower them down. They're still running. And then we'll get into the next day, and then instead of putting them online in the morning, we just start bringing them back online to higher outputs. They stay online, but bring them up. So those 17 events last year these are the operating hours by units. Some of those hours, I'd say probably 380 of those hours, since it's the lowest steam one, these were probably all on together. So you can't really add them up and say that's the total hours, because a lot of these units were running at the same time. But the data I have shows for each unit how long it was operating. Now these 2 units, again, you know, might only run 3 hours during each event. But at Christmas, they were running probably, I think, 10 or 12 hours on the days preceding Christmas for the polar vortex. But in a summer event, 3 to 6 p.m., 3 to 7 p.m. is a pretty typical run. So in actuality, we're running, I'd say, less than 5 to 7% of any total hours of a year. So kind of before you start asking questions, you open up to the public, we're really the electric plant's at a transition point. We have increasingly amounts of capital needs that are going to be needed for long-term operation. And so we're envisioning that there's going to be future meetings where we're going to have to provide additional details on the generating components, capital requirements, other financial considerations related to what level of generating capacity will be available through the IMA contract period. And that's going to come through not only through these types of meetings, but also as we prepare the 5-year capital plan and the annual budget. I know I stepped through that pretty fast, and hopefully the pictures helped articulate what I was trying to explain, and I guess at this point in time I'd be happy to address any questions.
couple questions, Brian, and by the way, that was great 101 on electric generation. I recommend The Last Day of Night about the Tesla, and it's a great book, but anyway. Couple quick questions, and actually before that, if you haven't gone on the tour of the plant, it's really, really interesting. It's a must, especially the water part. Very, very interesting. Anyway, quick question. I noticed in the last, or second to last slide, generation runs were higher in 22 than 21, kind of significantly. And yet both, you could say actually more people were at home in probably 21 during the pandemic. Like in my household, I know our energy spend was pretty high because I all of a sudden had kids coming home from college and stuff. Are we seeing more events? Is this a trend? Is this because of more EVs? Is it, generally the greater, as we're transitioning to more reliance on electrical power, is this kind of the trend we're gonna see? And what do you think?
The trend that's on this is not, in my opinion, related to what's happening in Winnetka or your individual homes. What's driving these dispatch events is the market conditions in the PJM transmission region. So PJM region is from the ComEd service territory to the East Coast. And so power prices, closing of plants, weather conditions, unplanned equipment failures results in market signals that the agency finds it economically feasible to dispatch us. So meaning it's a cost avoidance. So they're gonna face some, because of market conditions, they're gonna have a very high price for power. And by running Winnetka, and then the other member that has generation in northern Illinois is Rock Falls, and by dispatching our generation, they can lower cost or save money, depending on how you want to put it, for the benefit of all 32 members. So these events, at least for these 2 years, are not related to anything that happened in Winnetka. These are, we did maintenance runs. We had our quarterly hours that we had to run, but the number of dispatch events is for forces outside of Winnetka.
Okay, so thanks for explaining that. But would it be safe to say that the demand for electric power market-wide is higher? Or is it projected to be higher, or? I don't know the answer.
I'm trying to think of some of the forecasts of Sam. It's projected to go up, but it's actually not rising as fast as I think most people would say.
Okay.
But I think things that affect it is closures of other plants, so
Yeah.
generating resources are not there. And then other events like, really weather is a significant role. So a heat wave is gonna generate, or this polar vortex is gonna generate scenarios where they're gonna need us to generate.
Okay. And then, I'm not going to jump ahead to future discussions on this, but I'm just kind of curious, when you look at the age of these generation, whether it's steam or diesel, are there new technology, and again, I'm not suggesting that that's where we're going. Please don't. But I'm just curious, curiosity is killing me. Are the new generation, are they making new generators? There's not a lot of new power plants going up, that are, for little municipalities.
So there's, by any shade of any imagination, there's newer generating units than what we currently have. So at the simplest level, diesel generators are readily available. You can buy a diesel generator that's fueled by natural gas instead of diesel, similar frame or structure, that are emission compliant. It's like your car.
Yeah.
So your current automobile has the latest emissions technology on it, but there's a base level of what's considered acceptable. And so emissions technology on an efficiency on, say, a 1986 unit is not the same as a 2023 unit.
Okay, great, thanks.
Brian, I'm sorry, Ken. Want me to go? Sure, I'll go.
Okay.
Because I want to go sort of back to the beginning. First of all, thank you. To Tina's point, this was an excellent primer. I learned so much for all of us lay people whose electrical experience probably extends to flipping our breaker switch at most, and take it for granted. But actually, is that true or what? Yeah. Just sort of stepping back to make sure I've got this in context, and bear with me while I sort of repeat back. At one point, our electrical plant produced all the electricity for Winnetka, right?
That's correct.
And then at some point, obviously, we did not have the capacity, so we entered into an arrangement with this IMEA.
So there was actually an interim step. So this is in the 70s, as load in the system got larger than what the power can produce, they actually contracted with ComEd, and we're buying power from ComEd.
Okay,
So for a good 2 decades, the village was generating power and buying power from ComEd. It was in 1991 when we actually decided that we would buy our power from IMEA, and that's when we actually first became aligned. And actually, the person in my seat was one of the founding members of the people that got together and said there's got to be a better way to get power from municipal electric entities.
okay, and so that, one of the reasons we are doing that necessarily then maybe not going through ComEd is because we happen to have, because we have a power plant and can be a generator.
Well,
Provider.
actually, the rationale for going with IMEA is really not related to the power plant. Is the size of the village from an electrical load perspective, and no offense to anybody, is we're small. And so the theory is buying power of more people, 32 now, is better than the buying power of 1 or 2 of us. So the village went into IMEA, and at the time it was not 32 members. It was less, I think it was like 20, it's gone through different steps, but it was definitely less than 32. Is those communities gathered together and said, we want to aggregate our power, buying our power together. If we're all together, we're more enticing, more economical scale of economy. The power plant, when the village negotiated to go in, the village said, hey, we have this asset that can help you, but we also need to get money out of it for us. It's got to be
And that's our
win-win.
1.4.
That's the 1.4 million.
Okay, so is that why, this is more just a sidebar, I mean, I've lived here almost 40 years, I think the number of times we've had an outage where I've actually had to go to the trouble of pulling out candles for a couple hours, I can count on one hand. And I've always sort of bragged that, yes, everybody else who's got ComEd can sit for hours, days, weeks without power, but we don't. Is that because the 32 organizations, in a sense, can really work to balance, or the
So-
IMEA can work to balance and get us our power?
So generally our outages are, and I'll say since the time I've been here since '07, any outage we've had have not been related to a power supply issue from IMEA not delivering power. When we have an outage, most of our outages because a squirrel got into the wrong place at the wrong time, or a tree came down. Occasionally there'd be a cable fault or a transformer failure. Those are not power supply issues, or, and sometimes during a large outage, a storm event where a lot of trees are down, customers will call and say, turn the power plant on. Okay, the power plant may or may not
Like a
be.
breaker switch, you just go in the
The power
basement,
plant
flip
may or
it.
may not be on, but it's really not a power supply issue. It's that distribution system in the middle where a component has failed, a tree limb coming across the line, the squirrel. And so it's not where we need the power plant because we had a shortfall in the power supply. Now, the benefit of IMEA in that event is if we had a large outage event, 2007, August, I won't ever forget that, is 4 other municipalities sent people, crews, here to work. And so we had linemen from Princeton, Rock Falls, Naperville,
yeah.
4 or 5 days, depending on when they got here, working to restore our system. That's the benefit of not only IMEA, but also the municipal electric system in Illinois. Some municipals, Springfield being an example, Geneva, do not buy their power from IMEA, but they're a municipal electric system. So they run their own electric, but they've chose not to buy through another entity.
Okay,
But the difference to us in Wilmette is Wilmette doesn't have dedicated linemen.
Right, so, correct. So Wilmette, an outage in Wilmette is depending on the size of the outage, what other ComEd resources get spread across northern Illinois from ComEd, and they have to prioritize which individuals get picked up first. The benefit here is that you have the linemen are your employees and dispatched solely for the benefit of Winnetka.
Which is why when a tree's down, we get our power
Then you
back
have linemen
very
there.
quickly.
Yeah, so right now there's 4 individuals that are on duty tonight. If a tree comes down, 4 people that would be the first call that are waiting to get that call to come in and start the restoration process.
Glencoe back in that '07 event, didn't they wait weeks for Edison
Yeah.
to finally respond to them? I mean, they
Glen,
were people
yeah.
that were out for a long, long time.
Glencoe and Northfield both had, our outage was extended, but they had extended on top of extended.
That's all I get for now, thank you, I wanted to get that context.
So for more context, Brian, just maybe just getting to the root of the matter, why we're thinking about this at this moment. So if I understand correctly, the distribution system that we have is in pretty good condition?
Yeah, we're,
Any
yeah.
big capital needs on the distribution? For
So
the
the-
ComEd tie lines, for the Northfield substation, coming out of the power plant?
So on the distribution system, we've been, I'd say, above average on our cable replacement. Actually, at the next council meeting, you're gonna see funding approval request for buying cable for next year, for cable replacement. So we've been targeting, pre-pandemic, we were targeting about 1 mile a year of replacement infrastructure. There's some components in the distribution system that need to be changed out, but for the, well above that it's a much newer system than the age of the power plant.
Okay, okay.
And the other focus on the distribution system was getting the substation improvements done, so substation expansion. So without having the second transformer installed, we were really needed to have the power plant because that was the third leg of the stool. Previous village manager Doug Williams called it a 3-legged stool, the tie lines, the substation, and the power plant. And on any given day, when he hired me, he said, you gotta have 2 of those legs to keep this place upright. Which was if the substation transformer trips out, you have to have the tie lines and the power plant. So now it's a 4-legged stool. You still only need 2 legs, but you gotta have 2. So the beauty of the substation expansion is it gives this council and future councils additional consideration on decisions related to the power plant and what investments should be made
For generation.
for generation.
Right.
Prior to putting the transformer in, we needed that as part of our system contingency.
So if you were, back to Kim's point, if you were a business and you're looking at this, your revenue is 1.4 million, and your expenses aside from variable labor and stuff like this, your main expense is essentially depreciation of equipment over time.
We're past depreciation on
No,
this
I understand
equipment.
that, but if you were doing this, if you're doing this new, you would have to make that calculation. Does that capital investment, is it justified by 1.4 million? And I assume it doesn't go to 1.45 million,
No, it's-
1.5 million.
So that's the irony of the contract that we entered into for all the members is the 1.4 has been the 1.4.
Yeah.
With few exceptions in the actual testing, there's been a little variances in our testing output, which is done once a year, that fixes those numbers. The 1.4 was the 1.4 from 1991, in essence.
Yeah, yeah.
Okay, and there's no provisions in the contract for us or the other members that says it's tied to CPI, tied to our employee salaries, tied to, now, the flip side of balancing that equation is there has decidedly been years in my tenure with Winnetka where the agency did not get $1.4 million
Right.
of benefit from our generating units. Market conditions did not necessitate us running, and they still had to pay the 1.4 million.
Right, but if you see more generation plant going down, and we're going out to the East Coast with our, IMEA power, then,
So the decision, and Trustee Dahlman hinted at it, and this is the primer to what's coming, is we're gonna have to bring you the business cases, the reality, and the alternatives on what you wanna do with the power plant components. It's not a 0 or 1. It's of that intricate system, the boilers and the turbines and the feed water pumps and the hot well pumps, is that if we want to run it, we're going to present a case that you have to fix it, you're going to have to the 2035 timeframe, which is going to require this investment. Here's some other alternatives that you could consider doing in financial considerations for that.
But Brian, unless you can, I'm not saying you, but unless unless a business mind can justify that capital investment, that plant and equipment and so on, to be supported by 1.4 million or whatever the new contract offers, if you can't not you, Brian Keys, but if it can't be justified, you wouldn't go into that business.
There's one scenario I can think of where I could change your mind on that.
Okay,
So
good.
the water plant does not have elevated storage. We're required to have diesel generation for our water system because no electricity means no water.
Okay.
So I could pretty comfortably convince you that at some point in the future, we will need to replace our diesel generators.
The diesel generators.
And
yeah.
the discussion really would be on what size unit.
Okay.
And while I kind of glossed over it, we can run the diesel generators and run the electricity all the way out to the Hill Road pump station off the diesel generators. And that's part of the reason why those circuits stayed at 4 kV, so you could take generator output and run it all the way across town and feed the Public Works building, the reservoir, halfway across town, your public safety building, and the Hill Road stormwater pump station. All can be sourced, actually 2 different directions, one from Northfield and one from the power plant.
With 2 diesel generators?
Well, so this is where it gets into the discussion to come at some later date in time. Is it 2 diesels? You know, if you only get one and one goes down, then you for whatever time you're getting parts or maintenance on it, then you don't have 2. So this is really a prelude to some very interesting, complex discussion. There's maybe not one universal answer that everybody will agree on.
But to Kim's point, I mean, I think the feeling around town is that, gee, we're independent. You know, we operate, we've got our own staff, we've got linemen, you know, we have redundancy, and so we're really in good shape here. Without generation, that doesn't really change our independence and our redundancy.
So again, it hasn't happened in the time frame I'm here where have been, you know, I always say I have always, because that's what comes back. But we've been able to we're hooked to the transmission system, so we fare a lot better than other municipalities that are hooked to ComEd's distribution system. So we do have those tie lines, the 12 kV lines are hooked to ComEd's distribution system. Let me give you a comparison. One of our Northern Illinois members is served by ComEd's 34,000 volt system. That's really a sub-transmission or really a distribution voltage. That's not nearly as reliable as being served off the 138,000 volt transmission lines. And we're in the middle of a substation corridor. We've got substations to the north of us, substations to the south of us. So having a power plant that's great. But we're in, you know, other communities function, Naperville being one, has no generation. They're on a transmission system from ComEd. So it will come down to a financial consideration and what level of redundancy the village desires to have for the source of electricity. Now, as you look at how we are today, the generation we have will not support our entire system on peak summer days. Remember, I talked about 40,000 nominal kilowatt hours on a peak day? And with all the generation, everything working perfectly, we're at the 34,000. So there's a shortfall. Already we're living with a shortfall on peak summer days. For generation. Well, but correct, for generation, but if you're looking at it as we could run the place as an island, there's some periods of time during the year where we could not run. Now today, before I came up here, we were running at 19,000 kilowatts for the whole system load. So it's cooler, it rained. It's cooler, it rained. So we're not anywhere close to our system peak. So again, right now, you could run the whole village off the 3 12,000 volt lines from ComEd without Northfield or the power plant.
But Brian, to that point, and taking it from the village independence conversation and then also to where we sit within IMEA, are they relatively inefficient and costly relative to other generators on the grid? So like, do they come to us? Where in the stack do they come to us?
When you think about the age of the boilers and that they were converted
Yeah.
and the age of that generating system, it's by far not the most efficient. But then the flip side is if they're coming to us to run, then you know they've made a painful decision because we're the
Right.
lesser cost
Right.
provider.
Right.
Okay, so market conditions, like I forget the numbers, but that Christmas, the 23rd of December, they were like, they would have, if I had 6 diesel units down there, they would have said run all 6. Because that's how bad the northern Illinois and southern Illinois transmission system was, a shortfall of generation, that they were thrilled to have 2 diesel units running.
But
In
would
fact, we went through a discussion about, is it financially viable to turn the steam boilers on in the middle of that situation? And there was, for a period of time, I thought that's really was gonna happen. That's how challenging the northern Illinois system was.
But would it be the wrong way to think about this, to say we're likely going to have more and more generation come online with more efficient systems, so we're going to become older, more costly, and so eventually the likelihood of us not being called on might rise? Or is that the wrong way to think about this?
I think that's subject to a lot of discussion, and I'd say right now, in the absence of storage for renewable energy, I don't think you're gonna see any new power plants coming online. What you're seeing is actually
Right.
power plants coming offline.
Right, right.
And so until battery storage for renewable energy technologies, so you can always have that renewable captured to use when you need it, is readily available, I think at the transmission level, it's gonna continue to be constrained.
Got it.
Yeah.
So that just kind of fits into one of my questions. How many of the 18 or 19 people do you think are having the generators are having the same discussion? And how many are newer than us and how many are older than us? Could it go down to 15? What if we all say, oh, this isn't worth it? Then what happens?
So I can't, pardon?
Well, if there's infinite amounts of suppliers and people individually in their villages make decisions that it doesn't make economic sense to redo them, where does the energy come from?
So again, at the high level, organizations like Naperville, St. Charles, they don't have generation. So the agency is getting that power from market purchases, whether short-term or 20-year purchase power agreements, or their ownership interest in the 2 plants, Trimble County and Prairie State. As a member elects to, say, not replace a unit or retire it, then that generation, in our case, let's say 30 megawatts, they'll have to go look at finding however they figure how much they need to use from us a year, they'll have to go find that somewhere else in the marketplace. Some members, I don't have a statistic where I can say how many, I can tell you some members have retired units, and usually it comes with a catastrophic failure where they look at it and say, the price of replacing this drive shaft in this 1978 unit is just not going to be feasible. Other individuals, when we were required to put catalytic converters on our engines, use that stepping off point to go buy new diesels instead of retrofitting catalytic converters on their units. So some members have done both. There's like 18 or 19 of the 32 that have generation, so there's a large portion that has no generating units.
Does that make us more valuable then?
Well, the thing that, we're at an interesting point in the time for both Winnetka and the agency, because our contract ends in 2035. And they're currently not in a position to tell us what the value of that generation is going to be for them, and that's a long time off in market conditions. The observation I would offer you is it's very cumbersome to use our steam plant because it requires 8+ hours. And I know that on some times they're hedging, saying, I think I'm going to need you tomorrow, so I'm willing to incur the cost of you starting the boilers, and I might waive you off and not even have you run the turbines. But we think you need it. Now, the diesels have the ability to respond quickly And so if I was gonna speculate, I think longer term, some type of quick start technology is where it's gonna have value beyond 2035. The steam plant that's, I think is guaranteed through 2035 if the village keeps it running. After 2035, it'll be what value does the agency place on it and do we stay with IMEA? 20. So, right, so. Well, again, so that's, if you look back in my tenure with the village since 2007, I know there's some years where the value to them was, we're spending 1.4 and not getting 1.4 out of it. On the converse side is when there's been other years where I know they made more than 1.4 from having us in Rock Falls run to cover some events in the transmission system.
And they pay for the fuel at whatever the current
Whatever the
market
current
price
cost-
is.
current market price
So that's interesting
is.
that the cost for them will fluctuate, but that.
Right.
Okay.
So part of this analysis will be looking at what is our investment over the next 12 years with this existing frame of contract related to the age of our equipment.
Can we keep enough if we lose the steam? What can we generate?
Just nominally 5,000 kilowatts, that's the small part, and it's also the one that pays lesser amount. So remember, in the I'm sorry, President, it's not 0 or 1. Okay, so as we present this information to you, is like there may be decisions on, we replace this, we don't replace this, and we're gonna run it for a period of time, and then at some point, this particular component, turbine or boiler drops out, and our credits drop to a different level. Or we're gonna put in new generation of maybe a different type, and we have to go back and say, okay, what's that look like?
So the 1.4 million. Help everybody at the table understand what that money facilitates.
Or what happens if it goes away?
Now, well, because one of the things that a lot of people don't understand is the electric utility is responsible for paying the village. And I know you hate this, but it's payment in lieu of taxes. And so, out of all your revenue sources, you pay Rob. Pay us. You pay Rob.
So there's
So help everybody understand the numbers around those sorts of things.
I might,
And how much actually goes to the bottom line of the general fund budget?
so at a high level, when you look at our wholesale bill, Tim, I don't know if you have the numbers for purchase power for the year. I'm sorry.
Yeah, so just looking at the purchase power, in 2023, we budgeted $10.1 million for the purchase power. So in absence of this 1.4 million credit, it would be $11.5 million that we would be spending.
So wholesale bill goes up, and to the comment that President Rentz made, and it's been a subject of a lot of discussion, that's why he's poking me. The electric utility pays back to the general fund two separate amounts. One that's called payment in lieu of taxes, and one that's called administrative services. Payment in lieu of taxes is just that, it was this amount that's remitted. We don't collect a tax or for the value of the real estate that we take up. It's coming back to the general fund. Administrative services is for all the assistance I get from Tim, Rob, Kristen, Peter. That's my share of the corporate expenses, HR, for the maintaining of the water and electric organization to keep us moving forward. So I think it's nominally, Tim will correct me, but the two of them together is, I think, around 1.8 million. Am I close?
Yeah, that's around that.
So what would, in theory, losing the it's a balancing act, so we have to look at the projections of what we're gonna have to expend to keep the 1.4. On a simple approach, if we do away with the 1.4, we're gonna add another 1.4 to the electric bill, and then we'd be looking to figure out how to allocate that across our rate classes or seek reductions other places.
Wouldn't other expenses go down, though, if we didn't do this, in terms of
Well,
staff? And obviously, we wouldn't have
Actually-
even routine repairs or,
staff doesn't change. We've looked at that.
Okay.
Potentially closing maybe reduces headcount by one FTE.
but not to the tune of 1.4 million?
It's not
that we
1.4
okay.
million. So, and then you still have to, the building still got, you're still gonna have to, the infrastructure of the building, you're not gonna be able to get away with because it houses the water plant is part of it. It has the 4 kV circuits that serve our actual customers. So you're like, you're gonna still have expense for the building. What you're gonna not have is the maintenance and repair directly associated with boilers and
boilers,
turbines. You're still gonna have your diesels, because we're required to have diesel generation for our water plant.
Does the capital expense go into our electric rates? Into
Yeah,
our-
capital expense goes in your,
So the capital expense would come down, but be offset by the loss of the 1.4 million.
correct.
I mean, is there any idea what,
That's a future meeting.
okay, but I mean, that's,
It's
yeah.
it's unfortunately very complex, and it's gonna also has, I'll be candid, some emotional components to it because of the early 1900s, we were generating our own electricity, and then up until the 70s, we were an island. We did our own thing. So there's financial considerations, belt and suspenders on the contingency of the system, and an emotional component, and then there's a regulatory component.
What's the emotional component?
There's a,
Do we feel good about it? Because it gives us a sense of security and independence, knowing that
Sort
we
of like
don't-
what I was
knowing
saying,
that we
yeah.
don't have to deal directly with Commonwealth Edison and
Oh, I understand
Exelon.
that, but do we, that's what I was getting at earlier, do we lose our independence by not generating
well,
from
there's.
the steam boilers? And
There's some intrinsic value of, you'll hear it from individuals in the community, of some intrinsic value that we own our own power plant, and if need be, we can run our power plant.
But that's not necessarily true. I mean,
I understand, but there's also a portion of our customers that think the power plant runs every day, and there's a portion of our customers that think that when there's an outage, turn the power plant back on. So, I mean, there's a lot of education that comes with this topic.
okay.
I'm curious, I'm assuming that through, and maybe this is a wrong assumption, and maybe you've already talked to us about this, but I'm assuming our cost of power through IMEA is less than what the same hours would cost through ComEd.
Well, I don't think I have any,
Have we done that analysis
so let's back up. So we're,
on a kilowatt?
on a residential level, right now, when we did the last budget presentation, all in IMEA power costs, our system costs, which includes our capital, our employees, line trucks, were lower than ComEd or equivalent, or lower than ComEd. We look at that as part of the budget process every year.
Without all the state subsidies that
With-
Exelon enjoys.
Right, so we look at, here's what you would pay if you're a ComEd customer, here's what you're paying Winnetka customer. From a wholesale power, we're contractually obligated through September of 2035.
No, I get that.
The,
We go way up in 2035 is what you're saying.
no, I'm saying in prior to getting to 2035, the village will have to make a decision about re-entering into an extension contract with IMEA or going somewhere else after September of 2035. From my perspective, this community is too small to go it alone. You have no bargaining power, you're too small, and you have a load cycle that's predominantly residential. So you have your load goes way up when we all come home, and then in the middle of the night, it drops off. It's not a favorable load cycle to serve.
And to Brian's point, we're not scaled to go it alone. And
That's-
we have to contract out for those types of purchasing arrangements that we don't have the skill set.
We're not scaled because we can only go to 34.
No, we're not scaled to be in the marketplace to acquire power,
So that's
okay?
Not
So,
generation, just
not
buying.
just buying.
power.
So there's a whole,
So being a member of IMEA, we have that collective buying power in the marketplace.
Never works. 32
32 members, yeah. So what we have is they have a hired staff of people that their job is to run that agency and 32 communities send a elected individual down there to represent their interests on the board and make policy decisions.
I think
So-
in that magazine, that Power magazine that was in our packet,
Yeah.
I think it showed IMEA is like the 29th largest generator in the country. Was it generator? I think it was.
Well,
It
probably,
wasn't
it's
revenue.
probably joint action agency is the term they use, because they're not solely a generating organization, but they're procuring policy. So they're considered a joint action agency.
Yeah,
So
the
they have
point is
30,
it's a big organization.
it's a large, I mean, they're buying for Naperville, St. Charles, Winnetka, Rock Falls, Princeton, Rantoul.
I actually have never heard of Rock Falls, so I don't.
It's out in the west. So the decision that this is, there will be a time and a place for an IMEA discussion, and obviously whenever the President Rentz and Rob want to tee it up, but this was a shorter-term focus and background on, there will be power plant decisions that will have to be made coming up on equipment and capital spending. So some real easy ones that we've, turbine overhauls are about $750,000. We need to do 2. In the 5-year plan, we have one of the boilers is having continued tube failures that requires us to take it out of service and make repairs. And not to do a full retube, but a partial retube is 1.4 million-ish. We're working to get that refined. Those are in the next 2 budget years for the electric fund.
So I guess that's what, I guess you just started that, if you're up in our shoes right now, what is your what is the health, what is the executive summary of what we should?
So the executive summary is we're gonna bring you back some more information. We'll probably present a recommended path of consideration. We'll probably answer lots of questions, and then you'll give me some guidance on which way you'd like to see staff go, or potentially come back with additional information. This is giving you the context of how the power plant currently interfaces with our distribution system, so that as you get to those points, you have the context of how it fits, and have, say, some premise of what questions you need to ask staff to make sure you're comfortable with making an investment in the power plant and how it's gonna interact with the system.
So what keeps you awake at night so we can sleep?
There's a lot of things that keep me awake at night.
Turbines going down.
And I'm gonna say right now is one of those things, actually, one of the things that keeps me awake right now is unfortunately the water system more than the electric system, so let's go there, but. Yeah,
So, just so everybody understands too, is I've asked the EFC to start working in earnest on alternative generating options. So we can at least look at that and understand what technologies are out there. Patrick's been talking with Brian fairly regularly, and they're going to work and come to us with some recommendations. This isn't a decision that we're gonna make this year, just so everybody understands. This is gonna be, probably, this discussion will go on after I'm gone.
No.
So, I know we're all inclined to, be decisive and make decisions, but this is really complicated, and there's a lot of moving parts. And it just isn't what's cheapest today. We really have to think about this in a 50-year increment.
Yeah.
And understand what we're gonna leave behind with the decisions that we make. So, we have a lot of learning to do, and this first meeting was just to get everybody engaged. Get a couple of little bits and pieces here, and, those of us who've been here a little longer know a little bit more, but, it's gonna take a while. And it's gonna be iterative. It's gonna build on each meeting that we go through. Patrick had some fits and starts on the generating conversation, but you guys are geared up now, and it sounds like things are moving forward. And, we're gonna get some good information from them, and they'll come back with their own separate presentations with us too.
One question though, can we really separate these capital improvement discussions from the greater scheme of IMEA? Because they have to be, they're intertwined,
So if you look at this,
right?
as I mentioned, between now and 2035, we got 12 years, roughly 16.8 million in capacity credits. And how much capital do we really want to invest so that we're hopefully to the good? The capital repairs that Brian has identified, those are pretty short-term. Given the age
Okay.
of the equipment, there's probably gonna be more. So, but if you start at 1.4 million times 12 years, that's your,
Yep,
that's the credit that we have, and how much can we get out of that to the end of the contract.
yep.
So that's one path, and then the second path is the next contract with IMEA. What does that look like? And then there's another path, which is alternative generation. These aren't all gonna be hitting at the same time.
But one of the, and this is where, I've been thinking about this way too long, but the fact that Brian's operation actually goes to the bottom line of our general fund is really an important piece, and it's something that shouldn't get lost in the thought process here. Because if we don't have that 1.8 million that he's coughing up to Rob every year, we have to levy it. And our levy was what, 16 million, Rob? So that's more than a 10% increase in the levy just to cover that piece of the trans. Now granted, even if he was operating, there would be some of these payment in lieu of taxes and some of these
Sure,
other fees,
sure.
but at some
Generational-
point, it's gonna come out of our
generational.
pockets. I mean, we just can't manufacture money out of thin air, or out of steam for that matter, right? So it's just something to keep in the back of your head, is there is a bigger financial impact than just our electric bill. It really goes down to what we levy and what our tax bill looks like as well. So it's a profit center, plain and simple. And even though it's not profit, but it is a center, it's a revenue center, I guess is a better way of putting it. And one that's been really good to the village for many, many years. And it's something we have to think about a little bit deeper than just, cut the cord and hope that Exelon gives us a good deal on power coming into the village. So something else to think about. So other questions for, I did have one more technical question. As you're ramping up those steam generators, are they actually generating during the ramp-up period as well?
Yeah.
At a lower amount? I mean,
So
the
there's,
second those things start-
so there's a point in time where they're spinning and they're not interconnected, so they get them rotating to a certain RPM, and this is where I'll conceptualize. They get it rotating a certain operational RPM. They'll close in the field breaker that will then interconnect it with the system, and they're actually generating. So then they start ramping it up until they get to the desired output level.
Gotcha.
And when you're if it's not an emergency, they're gonna, to make it as easy a transition on the equipment as possible, is you basically bring it up to, you're bringing it up in incremental, nice and slow, bring it up, let it get warmed up, move it up a little more. And so you usually have a whole schedule built, like a time schedule that says, okay, IMEA wants this output at 4 in the afternoon. We'll start here and we'll just start ramping it up so that 4 o'clock we're at the desired, whatever the specified output is that they want at that point in time.
But shortly after you fire up, let's say, or, during the ramp-up period, you're still sending some power out on the grid.
Correct,
Just not the required amount.
not the full amount.
Right.
And then the specified amount is usually only for a very specific window. So there's periods of time where we're putting power on the grid, and they're paying the fuel and the 3.003 per kilowatt, but generally it's like, we need this output at this level for these very specific hours.
We hardened our targets before. I remember those stations over by the CarMax dealer.
So that's probably a topic for discussion outside of this.
No.
Agreed.
Other comments, questions, discussion with Brian?
No, this is excellent.
Great,
All
Brian.
right, well, let's
Thank
open
you.
it up to the audience.
Thank you.
Would anybody like to share with us?
Yeah, I mean, I could, so, the only thing I would say, and by the way, hello from former trustee Ann Wedner, because I'm Marcus Wedner. I used to come to some of these events just to be supportive. And Brian, you and I had a conversation not long ago. You guys are probably already focused on this, and I think the nature of the discussion here is really pretty good. I would just urge, you guys, the trustees, when you're laying out the different alternatives, I know there's sort of the short term, the medium term, and the long term. I would just say I think people might be interested in what, the emissions profile is of each one of these choices, right? And there's the methane part, there's the CO2 part, there's local pollutant parts anytime you're burning stuff, whether it's diesel or whether it's natural gas. So, Chris, as you're saying, hey, this isn't, you know, purely a question of, hey, you can kind of unplug and, but there's other considerations. And I would urge people to sort of focus on the emissions piece of it too.
So just to build on that point, very true. So the air permitting for any type of generation, so diesel, natural gas, we're in an area where it has very strict air permitting requirements. So that would be a part of the cost to implement desired changes in generation. Permitting is a sizable piece of this.
Thank you very much.
Thank you.
You know, and the other thing that I might add from, you know, from the EFC perspective, you know, part of their mission is to start to shrink our carbon footprint. And so certainly a lot of what they're looking at is going to be that sort of conversation. Again, and that's where the visionary part comes to, right? I mean, what do we want to leave behind? Some that's spewing out emissions that are okay in 2023, or do we want to leave behind something that, you know, is much more environmentally sensitive and appropriate, or even zero, right? I mean, of course, cutting the cord and just buying from Exelon, we feel good about what we're doing because we're not creating any carbon footprint at that point in time, but our suppliers too. So there's a lot of other thoughts. And
let me just yes and what you're saying, Chris. I think one of the things that the EFC is excited to think more about and more broadly about is what partnerships we can leverage at the state level, at the national level. There's a lot of attention and investment going into similar projects, lots of different pools of money, lots of different sources of grants, as well as loans, as well all sorts of different financial instruments. And that's something that we should just know about as a village and put into our consideration set as we think about different options going forward, because there's a lot of attention from other places on reducing emissions.
And I think you can just about bet on the fact that if you're taking money from a federal resource or a state resource, there's going to be a lot of carbon footprint strings attached to that money, as it rightfully should be at this point in time. So, Tom, I saw you had your hand.
I did. Quick question, thanks. It's a fascinating topic, and Brian, I second all the accolades for the presentation. And I'm sure with the data dump you said this, but if you could kindly repeat it for me. Managing expectations, what is the reasonable remaining useful life of these 5 very old generators? And I'm trying to think of identifying the point at which there's basic maintenance, you replace a turbine. I don't want to minimize the cost of these things, but when the costs reach the level of being truly material, how quickly do we ramp up to that? Is that tomorrow? Is that 10 years?
I think, as I mentioned in my introductory remarks, we're at that transition point. So, I mean,
Help me understand that.
We're getting on some of the equipment, and I'll use number 4 boilers specifically, we're going to need to make a decision that's somewhere around $1.4 million to keep it in service. And so for that component, we're going to have to make a decision in the nearer term on whether we want to expend money to retube part of that boiler to address the failure component. From a book life perspective, I think, you never say everyone, but the vast majority of people would say we fully have depreciated these assets and they're at a renewal state.
But the other piece to that is that
they're running.
That particular unit generates $415,000 a year in revenue.
Right. So
it's a 3-year payback.
So it's a 3.
11-year.
Right. So that's the again. It's not to say that this should be shut down, but it's we're going to have to make a repair that's 1.4 million, and on that same on a corresponding turbine another $750,000. So we're going to your point, we're going to have a 5-year payback or a 6-year payback on an investment that we're going to make in the next 2 years. And so collectively, we've got to bring this organization the data and other data to help get to a decision point on, is there general consensus, meaning a contract award that we should do this work, or are we gonna put it on one or more components on a sunset path? At the same time, other technologies are being looked at to potentially be implemented. But in the near term,
Got it. Yeah, I think I'm getting to a better understanding. 2 years, we have $1.4 million problem. The other 4, a longer-term useful life expected, or?
yeah, I mean, looking at how they're performing now, if we do one of the overhauls, is the other 3 boilers have had maintenance issues on occasion, but nothing like boiler number 4. So they're still performing reliably. Number 4 has been performing to the level of every second or third time that we use it, we've got to go in and do a tube repair. Meaning that a tube fails, it's kind of like a water main break on the street. And so it impacts our reliability of being online. The diesels are running fine, and I always hate to say, but they're installed in 1978, so there's going to be a point where we're going to need to replace them. I'm fairly confident that we'll have to replace them because of the water plant. And the discussion will be focused on the number of units and the size.
Thank you.
Great, thanks, Tom. Ted, you got anything?
Yes, I did want to say something. Ted Winnichenko. Can I ask a curiosity question? What is, going back to the emissions question, what is the efficiency of the natural gas and diesel generators about? Any ideas?
I don't have any idea that.
Oh, okay, I'm just saying, because if, that's another thing to think about in terms of emissions, is how much of that burning is wasted and doesn't go to electricity, right? That's lost as heat or whatever. But yes, I thought your question about, or your suggestion about storage capacity for renewables was interesting. I thought some of the comments about distributed systems was interesting. And I would like to go back to the fact that clearly, no individual homeowner is going to put up a 1 megawatt array on their roof, right? But we have a lot of people here. We have 5,000 homes. And if people put up a 5 kilowatt array, 20 people gets you to 100 kilowatts, 200 people get you to 1 megawatt of solar generation distributed throughout the village. And that's not a lot of people to get there. And that would really improve resiliency of the system, right? I know we've had some differences on this, but it would distribute the load, it would make the system more resilient, and it would be a great addition to the portfolio of power generation within Winnetka. And I, again, argue that the problem, the reason that such a wealthy community as Winnetka does not have more solar is because the payback period is too long based on the fact that this is a municipal utility. It's not required to follow the net metering standard. And so people realize that they aren't going to get back their investment quickly enough, and so they choose not to do it. So I know that we've gotten better from the days when it was all wholesale to now this mix of retail and wholesale, depending on the time of year, which gets you about 60%. I would suggest that we reconsider and just go straight to net metering, and I think that that would be enough of an incentive to push a lot of other homeowners into getting solar panels. And I know that the peaks don't match and the sun's going down when the peak is, but it would add resiliency to the system, and it would be, I think, in my opinion, a low-cost way of really strengthening the grid for everyone. That's just my comments, but I know Brian has, maybe we have some differing opinion. So.
Would anybody else like to throw anything at Brian? Okay, I think we're good for this tonight. So, item 4 is closed session. So I would like to ask for a motion to adjourn to closed session for the purpose of discussing, is this on? Yes. Hello?
Want to borrow Mike?
Hello? Can you hear me? Well, sorry, all you folks at home. I can't hear myself, so. All right, I would like to ask for a motion to adjourn to closed session for the purpose of discussing pending litigation pursuant to Section 2C11 of the Open Meetings Act, and discussion of minutes of closed session meetings pursuant to Section 2C21 of the Open Meetings Act. Under the motion, when we adjourn the closed session, this open meeting will automatically and immediately adjourn as well without the conduct of any further business or comments. May I have that motion?
So moved.
Second.
Roll call vote.
Trustee Handler?
Yes.
Trustee Dahlman?
Yes.
Trustee Dearborn?
Yes.
Trustee Appleton?
Yes.